Same type of problem this time. We have 3 fractions, which means we have 3 big terms in the equation. Every one of them is a fraction. We would absolutely love to get rid of the fractions. So to do that, I need to multiply everything by a common multiple of 4, 2, and 8. Well, if I start counting by 4s, 4, 8, 12, 16, start counting by 2s, 2, 4, 6, 8, 10, start counting by 8s, 8, 16, 24. There's an infinite number of numbers that would appear in all of those lists, but 8 is the smallest. So if I multiply everything by 8, that gives me 8 times x plus 3 over 4. I think I switched to my green too early this time. That's okay. Minus 8 times x minus 4 divided by 2 equals 8 times 3/8. Now again, the fraction bar means divide, so all I'm going to do is I'm going to go through and I'm going to divide. Let me pick a different color. Let's try purple. I have 8 divided by 4. 8 divided by 4 is 2, so the 4 cancels and that 8 can become a 2. So I get 2 times the numerator that did not get touched. So 2 times the quantity x plus 3. Minus, again, 8 divided by 2 is equal to 4 times the numerator, which did not get touched, equals 8 divided by 8 is equal to 1, so those cancel completely, and I get 3. Okay, there's that numerator that wasn't touched. Okay, distribute now. If I distribute the 2, let's see, I may as well go back to my green, I guess. Distribute the 2 into the parentheses. 2 times x is 2x, plus 2 times 3 is 6. Next, I'm distributing the minus 4. Don't forget to drag that minus along. So I'll distribute it to each term in here, so that gives me minus 4x. Minus 4 times minus 4 is plus 16, equals just regular old 3. Simplify by combining like terms over here. I have 2x minus 4x, which is negative 2x. And I still have the plus, let's see, plus 6 plus 16 is 22, equals 3. Subtract my 22 from both sides. So I get negative 2x equals negative 19. Divide both sides by negative 2. My negative 2's cancel, and I get x equals, again, it is fine to leave this as an improper fraction, but this time we have a negative divided by a negative, which is a positive, so we want to make sure that we keep it in its simplest form, which would be positive 19/2. Okay, next we have a decimal, or several decimals in this problem. There's absolutely no difference in working with decimals. I will distribute that 0.1, or that 1/10, to each term inside the parentheses. So 0.1 times t is just 0.1t, plus 0.1 times 0.5 just gives us 0.05. I still have that plus 0.2t, equals, if I distribute the 0.3, 0.3 times t is just 0.3t, minus, if I take 0.3 times 0.4, that just gives me 0.12, or 12 Okay, do a little bit of combining my like terms. 0.1t plus 0.2t is 0.3t. I still have the plus 0.05. Equals, the right side just stays 0.3t minus 0.12. I can now subtract 0.3t from both sides. And in doing so, something interesting happens. My 0.3 t's cancel out over here, and I'm left with 0.05 equals my 0.3 t's cancel over here, and I'm left with negative 0.12. When this happens, when in the course of solving your equation, the variable terms completely cancel out, you have to take a look at what you have left, and you have to decide whether it's true or false. In this case, you have that 0.05, or 5/100ths, is equal to negative 0.12, or negative 12/100ths. Is that true or false? Obviously, it's false. Since it's false, that tells me that if I go back up to the original equation, there is absolutely no number that I can plug in for t to make this left side equal to the right side. In that case, then, there is no solution. There's no possible number that will make the left side equal to the right side whenever I plug it in for t. Had this final statement been true, that would mean I could plug any number in for t and my answer would have been all real numbers. Okay, another one with decimals. If I distribute the 0.35, that gives me 0.35s, that's an s, plus, let's see, can't do that one in my head, 0.35 times 0.34 is 0.119. And then I still have the 0.15s equals 0.2s minus 1.66. If I simplify by combining my like terms on the left, I take the 0.35s plus the 0.15s, and that gives me 0.5s. I still have the plus 0.119 equals 0.2s minus 1.66. I apologize if my s's look like 5s. Okay, if I want to move my terms over, I would subtract 0.2s from both sides, and 0.5s minus 0.2s just gives us 0.3s. I still have the plus 0.119. My 0.2s's cancel, so that gives me equals negative 1.66. Now I can subtract my 0.119 from both sides. So I get 0.3s equals, let's see, negative 1.66 minus 0.119 is equal to negative 1.779. If I finish this one off by dividing both sides by 0.3, my 0.3's cancel out, and I get s is equal to, let's see, 0.3, negative 5.93. This particular problem is a little bit different in that we have fractions with variables in the denominator. So if you look at the different terms here, we have 2y, and then we have the plus 5 over 2, the 4, the negative 2 over 3y. With those four terms, 3 of them are fractions, and if I look at y, 2, and 3y, the first thing that I'm going to be able to divide all of those by is 6y. Okay, I look at the y's, and since the variable in them is both y, then I know y is part of my common denominator. And if I look at the 2 and the 3, the common multiple there is 6. So I want to multiply everything by 6y. Just think to yourself, what is going to make that denominator cancel whenever I divide? And it would be just a y. And then also you have to take care of the numbers. In this case, the 2 and the 3, they can both be divided. 6 can divide by both of those. So 6y times 2 over y plus 6y times 5 over 2. Don't forget the 4. We have to take it times the 6y also. Times 4. I'm kind of running out of room. Minus 6y times 2 over 3y. Okay, again, think of the fraction bar as a division symbol. Okay, your fraction bar just means divide. So, if I take a look at this, y divided by y. My y's cancel out. The 6 just stays a 6, so this gives me 6 times 2 plus 6y divided by 2 just gives me 3y. So that is going to be plus 3y times 5 equals, I still just have that 6y times 4, that's not going to change, minus 6y divided by 3y. Well, the y's completely cancel, and 6 divided by 3 is 2. So that gives me 2 times 2. If I simplify this now, 6 times 2 is 12, plus 3y times 5 is 15y, equals 6y times 4 is 24y, minus 2 times 2 is 4. Do my rearranging now, which we should be getting pretty good at. Minus 24y, minus 24y. So this gives me 12. And then I have a positive 15 minus 24, which gives me negative 9, or minus 9y, equals my negative 24's cancel, and I get negative 4. If I subtract the 12, I'm going to bring this up here. I want to keep this all on one screen this time. My 12's cancel, so I'll get negative 9y equals negative 4 minus 12 is negative 16. Divide both sides by negative 9, and I get y equals, again, negative divided by negative is a positive, so I will leave it as positive 16/9. The reason I wanted to keep this one all on one screen is because I want to emphasize the fact that in the original problem, I had variables in the denominator of fractions. I can never have a 0 in the denominator of a fraction. So anytime you have an equation that has a variable in the denominator, whatever answer you get, you have to go back to the original problem and make sure that plugging that number in does not put a 0 in the denominator of the fraction. If I plug 16/9 in for y, 2 divided by 16/9 is not 0. 2 divided by 3 times 16/9 is not 0. There's no way this answer puts a 0 in the denominator, so 16/9 is my answer.